These are the questions from the previous video. What is the limit of x of t as t goes to infinity? What is the limit of x prime of t as t goes to infinity? We can find these limits through the phase plane plot. To see it more clearly, let's change the upper limit of time t to 50. So I need my hands to do shift enter. We make the same change in the parametric plot or the phase plane plot. Another shift enter. So now we got a different plot. Notice that the initial point is missing because Mathematical decides to show more details here, therefore it cuts the window shorter, so it doesn't include a little bit of the beginning. So clearly both x and x prime go to 0 as t goes to infinity, since they are the coordinates of the points on this spiral. So the answer to both of these questions is 0. We can also see this answer through the individual graphs. So let's do this graph. I'm not going to change the 20, I'm going to keep it as 20. So let's do shift enter to plot x, and there it is. This is the graph of x of t, and notice that as t goes to infinity the limit is 0, and also we can see the initial position or initial angle minus 1.2, and the second time it passes the equilibrium position would be at this, around this time 5. So this is the first time that x is 0. This is the second time that x is 0. These are the time that the pendulum passes the equilibrium position. Now let's do the x prime. Shift enter. So we can see again that the limit of x prime is also 0 as t goes to infinity, and this corresponds to the initial point. And what about the second time the pendulum passes the equilibrium position, which was one of the questions, previous questions? This is about 5. Time is about 5 here for the second time, and at time 5 the velocity or the angular velocity is about minus 0.6, as we noticed through the phase plane graph. So this concludes the last video for this lesson, but let me leave you with one question. And also, aside from this question that I'm going to raise, you should post your own questions, make your own questions and post them on Blackboard, either about this problem or some other phase plane problems. I will post this mathematical notebook on Blackboard, so you can have the syntax in order to create your own plots with different equations or different initial conditions and so on. So the question that I want to leave you with is, when is the angular velocity the highest? You should use these two graphs. When is the angular velocity the highest in each swing, during each swing from one extreme to the next? When is the angular velocity the highest? And also think about it physically too, as well as looking at these two graphs. And also you can see the same answer by looking at the phase plane. So use three different means to find the answer, or to see the answer. It is really a very simple one. When is the angular velocity highest during each swing? One way is to use this plot. Another is to use these two plots, and another is to see it from the physical situation. Look at the pendulum and see the answer. This concludes the lesson.